Hello students, we'll start from the flotation of iceberg topic. As you know, the density of the ice is less than the density of water, and density of the ice is 0.917 gram per centimeter cube, which is less than density of water in CGS 1 gram per centimeter cube. Therefore, huge masses of ice known as icebergs are able to float on water with their major mass or part inside the water. To get the sufficient upthrust, only a small portion will remain above the water surface. Now, volume of iceberg above the water surface while floating. If the total volume of an iceberg is capital V and the volume of the iceberg submerged is small v, that is submerged part of the iceberg, then by the principle of flotation, as we know, small v into density of water into gravity, this will give us upthrust, that water displaced, volume into density is mass into gravity, and total weight of iceberg, that is the total volume into density of ice into gravity, this will become mass of iceberg into gravity. So mass into gravity is total weight of iceberg. So small v upon capital V, small v is the submerged part of iceberg in water, capital V is the total volume of iceberg, density of ice over density of water. Example, an iceberg density of ice is 0.917 gram per centimeter cube and density of water is 1 gram per centimeter cube. Now with volume 91.7% of total volume below the water surface, this much volume will remain inside the water, that is the 91.7%, approximately 90%, and outside volume will be only 8.3%, and roughly we are taking it as 10% of its volume above the water surface. An iceberg density of ice is 0.917 gram per centimeter cube, floats on seawater. Density of the seawater is 1.026 gram per centimeter cube. Now with volume small v, that is the submerged part of the iceberg. So density of ice over density of seawater. If you will solve this, you will get 0.893 of capital V. It means 89.3%. If you will multiply it with 100, you will get this answer in percentage. So 89.3% of its total volume will remain submerged, and rest of the 10.7% will remain outside the seawater. So icebergs are dangerous for ships. As we know, icebergs being lighter than water, they will float because it is made up of ice. So nearly 90% major part of the iceberg will remain inside the water, that has to submerge to get sufficient upthrust to balance the weight of the iceberg, and 10% will remain outside, since the portion of the iceberg inside water surface depends upon the density of the seawater. Therefore, for the driver of the ship, it becomes sometimes difficult to estimate the size of the iceberg. Thus, an iceberg is very dangerous for a ship, as it may collide with the ship and cause huge damage. No change in level of water on melting a floating piece of ice. When a floating piece of ice melts into water, it contracts by the volume equal to the volume of ice piece above the water surface. This much volume which is outside the water, and during contraction there is a decrease in volume, so they both are equal, so while floating on it. Hence the level of the water does not change when the ice floating on it melts completely. After that, flotation of fish. Many species of fish have an organ called a swim bladder. It acts like the ballast or flotation tank of a submarine. So when fish has to rise up in water, it diffuses certain gas from its fluid into the bladder, so its volume increases, or average density of the body of the fish will decrease as comparison to the density of the water. So this increases the volume of the water displaced by the fish to get sufficient or maximum upthrust on fish increases, due to which it rises up. When the fish has to come down or dive deeper, it empties its bladder to the required extent, so its volume decreases and density increases. So hence upthrust on fish will also decrease, and ship will go down according to her requirement. Last topic is rising of balloons. When a light gas like hydrogen or helium density which is quite less than the density of the air is filled in a balloon. Weight of the air displaced by the inflated balloon which is filled with gas will get sufficient upthrust, and that upthrust is quite large as comparison to the weight of the balloon. That's why balloon start rising upwards. But the balloon does not rise indefinitely. Why? Because one stage will come when it will go higher and higher, the density of the air layers will start decreasing, or you can say in simple words, the weight of air displaced by the balloon will start decreasing, and when it will just be equal to the weight of the balloon, at that condition, at that position, the balloon will start floating. It will not rise further. So it keeps on rising as long as the upthrust on it exceeds its weight. But when upthrust becomes equal to its weight, it stops rising further. So there one condition of flotation will occur, will achieved when the weight of the balloon will be balanced by the upthrust provided by the displaced air by balloon. So that's all for this part C, and in next video we will discuss numericals of part C of chapter 5. Thank you.